All right, everybody, welcome back to Math Videos with Miss Lastly. Today we are going to look at using our unit circle values in expressions. So remember, these aren't equations, right? Equations have equal signs. Expressions just are like statements of math stuff, right? So that's kind of our expressions, right? So we're going to look at simplifying some expressions using our unit circle values. So let's get into it. All right, so here we are. Let me zoom in a little bit. But these are what our expressions are going to look like. All right, so looking at the first one, we have sine of 150 plus 4 cosine of 60 degrees. All right, so what we want to do is we want to simplify this into just one number, right? So if you were simplifying like a bunch of fractions being added together, you would, make your common denominator and combine your fractions so that you had just one. That's our same thing that we're doing here. So we're just simplifying. All right, so we want to take these two terms and make it one term. All right, so first we're going to start by applying our unit circle values. All right, so we have sine of 150. All right, so we actually want to find what is the sine of 150 degrees. All right, so we want to think about our unit circle value. All right, if it helps, for me at least, I don't like degrees. I much would prefer to deal with radians. So I do this every time in my head. So 150, I always go back to what is my reference angle. So if I'm at 150, that's going to put me in this second quadrant. All right, so there's the 150. So then this is going to be my reference angle. So it's always the angle to get back to the x-axis. And I know that the x-axis is going to be 180. So like I'm just subtracting, right? 180 minus 150, and that's going to give me 30. So 150, those are my 30-degree angles. Okay, now if you have your unit circle sitting in front of you, or you have already memorized your degrees that go with your angles, then that's excellent. Like I said, I am not as familiar. I've been teaching this class since my 4th year. Plus, I have a math degree and I still don't know my degrees. Like I don't have them memorized. Radians are easy. I can do radians all day, and you'll understand why next year when you go to calculus, you don't use degrees anymore. So they kind of don't really stick with you. But yeah, so for degrees, I literally have to go figure out my reference angle every time I'm doing the problem to make sure I'm at the right angle. Okay. So since I know that I'm dealing with reference angle of 30 degrees, I think about, okay, what are my coordinates for my 30-degree angles? And those are going to be, so if I'm just thinking, okay, 30 degrees, those angles have my x value of square root of 3 over 2, and my y value is going to be 1/2. All right. And that part just comes from memorizing your unit circle. Now, one way that I was kind of taught to remember 30 versus 60 is the square root of 3 comes first, and 30, square root 3, right, they're close to each other, like literally, not metaphorically, right? The 3 in 30 is close to the square root of 3 in the problem. So those kind of go together. Also, if you look at the unit circle, all right, the pink circle is 60, and the darker circle is 30, right? Because 30 appears lower on the unit circle, like it's the first angle we hit when we go up. This length, the bottom, the x value, is longer with the 30-degree triangle, and the square root of 3 over 2 is a bigger number than 1/2. So that's another way you can kind of remember it, like the 30-degree has the bigger x value. Whatever helps it make sense for you. It's all about what memorization tricks work best for you. It's different for everybody. But those are the two things that I kind of think of when I'm trying to kind of memorize this unit circle. Right? Because I'm not, the most amazing, right? I teach unit circle and then I have a whole year go by and then I have to re-remember it to teach it for the next year. So sometimes little tricks like that help you remember it a little bit faster. Anyways, so I know that I want the sine, all right? And I know that in the second quadrant, my sine is positive because remember sine is my y value. So sine of 150 is 1/2 and it's positive 1/2 because we are in the second quadrant, all right? Because like I said, sine goes with our y value, right? Which is 1/2. Okay, plus. Moving on to the second piece. So I have 4 times the cosine of 60. So now I need to figure out what is the cosine of 60. All right, so 60, it's kind of nice because we already have 30 right there. So 60 is the same numbers, just switched, right? So you have 1/2 and then comma square root of 3/2. So cosine of 60, and this is just in the first quadrant, so everything is positive. Cosine is our, oops, I erased it, didn't mean to do that. All right. Cosine is our x value, so I'm just gonna look at my x value, and that is my cosine. So I'm just gonna plug in that 1/2 for cosine of 60. Now all I need to do is just simplify. So I have 1/2 plus 4 times 1/2, which simplifies to 2/1. All right, and I'm adding, so I need to create a common denominator. I'm gonna turn this, I'm gonna multiply by 2 on top and bottom, and then I can just add. So 1 plus 4 is 5 all over 2. 5/2. That's my answer. All right. So once you plug in your unit circle values, all it becomes from that point is just simplifying, adding fractions, that kind of stuff. All right, so let's go to the second one. All right, so same concept, but this one is in radians. So we're using our radian measures, which to me is easier. I always would much prefer to deal with radians than degrees. All right, so tangent of 5π/3. So anything over 3, those are your 60-degree angles, which is kind of nice. We have the 60-degree coordinates right up here above, but we just have to make sure we're in the right quadrant. So 5π/3 is going to be in the 4th quadrant, which means that my y value is negative. All right, so tangent of 5π/3. All right, so tangent is going to be y divided by x. So I'm just going to kind of plug it in off to the side, and then we'll simplify it once we get everything kind of plugged in. All right, so tangent of 5π/3 is going to be negative y, because we're in the 4th quadrant. So negative square root of 3/2 divided by positive 1/2, because x is positive in that 4th quadrant. All right, and we can simplify here if we want to, right? Keep the top, flip the bottom, and change it to multiplication. So the 2's cancel, and so I'm left with just negative square root of 3. All right, so that's on the top. All right, and if you want to kind of keep track below, you can. So we can say this is negative root 3 over. All right, and then I'm going to do the same thing over here. So cosecant of 5π/6, 5π/6, those are all of your 30-degree angles. All right, and 5π/6 is less than 1 full pi, so that tells me that's in the 2nd quadrant. So cosecant, and I'm in the 2nd quadrant of my 30-degree angle. So if you look, we have 30 degrees right there. Cosecant is the reciprocal of y. So our y value is 1/2, which means our cosecant value is 1/1/2, or, right, 2. And it's positive because it's in the 2nd quadrant. And cosecant, just like sine, is positive in the 2nd quadrant. So I'm going to go ahead and write that in my problem down below. All right, last piece that I have to simplify is the cotangent of 3π/2. So 3π/2, that's 270 degrees. All right, and my coordinates for that are going to be 0x, -1y, right, because we're going straight down by 1. All right, cotangent, that's x over y. So x is 0 over y, which is -1. So we have 0 over -1, which simplifies to 0. So down here, we have -0. So this simplifies to negative square root of 3/2, because -0 is just nothing, right? So that's our final answer for that one. Okay, so that is simplifying our trig expressions. All we're doing is we're plugging in our unit circle values into wherever they belong, and then we're combining like terms and simplifying at the end. That's it. All right, I will see you guys in class. Good luck on your homework.